Jan for the introduction. So I think it's a perfect fit in comparison to the last talk of Karina, because we also want to show you some insights of our daily business in our company here at Festo, how we try to overcome these challenges in the real world. So we have 3 parts. Also my colleagues Felix and Yannick, they will also take over some parts. I will start with an overview how we are set up here in Festo with our digital business, what kind of strategies we use to scale our business, what kind of architecture we are using, and also what are the known hurdles that we have to tackle every day, and how we try to overcome them. Then in the second part, we will show you a first real-world example, and we also have a second example. They differentiate a little bit also in the architecture and how we, which kind of use cases we tackle there. So this will be quite interesting for you as well. So my name is Steffen Schmidt. I'm heading the Solution Engineering Department at Digital Business. And I want to introduce our business here. So generally spoken, we are part of a larger scaled strategy of digitalization at Festo. So for sure, everything is driven by some technologies like data analytics, AI, more computing power, etc. For that, this is also used in our enterprise in general to digitalize internal processes like sales processes, SAP, less paperwork, etc. For sure, everything is accompanied with our colleagues from Didactic. I also see some colleagues here in the audience, so welcome. Digital education for sure is also a big topic. Here we are with our digital business as well. And last but not least, we also are working on smart products for sure. So focusing now on the digital business part here, I want to give you a short overview of our portfolio, which we call Festo AX, Automation Experience. So first thing, we also heard it in Karina's talk, data access. So we need data for sure for analyzing. So we have one software part to get proprietary data out of our Festo products, converting them into rather standardized protocols, MQTT. Then we have 3 different, I will, due to the time, I will show them in one. So we have 3 different areas where we focus with our AI-based software approaches. One is predictive maintenance, also quality issues and energy issues. All of them were also mentioned in the word cloud in the last talk. So I think we're in a good way here. To also work with it, we still have Festo AX Maintenance. It's a maintenance manager where you get rid of paperwork to also get more digital in your shop floor. And for sure, we can combine these streams to have a self-optimizing system here to get more information from the shop floor, and then also can turn it into tasks for the people working on the machines, and then get information back to even optimize our AI models that are predicting things. So I was also mentioning that we want to show you some strategic parts. So we go into 2 strategic directions within our customer projects. So I'm starting with the right-hand side because this is where we come from. It's a more holistic view and a larger scale project-based approach where we tackle specific use cases at customers. as a, for example, body in white area in the automotive sector. Yannick will later on go into more detail here. But what we want to derive from these projects is a standardization. And this is what we call AX Industrial Apps. And they are very specific on one use case, but this use case is more or less completely automated. So you don't need to have any AI-specific knowledge to do that and to use it, because it's very simple from a user perspective. So this is a very good and also cheap, let's call it cheap, approach to get into the topic and to get the benefits out of AI here. So what helps us to do that is our very flexible architecture. So every rectangle, every block that you see here is Docker-based. So we have a bunch of Docker containers here, which you can run on different runtime areas. So either on an edge device or on a virtual machine or even cloud-based, if you like. We will also see how we use that in our customer examples in a different way. So it's very flexible. We have the brain, how we call it. It's the AI and machine learning engine that does all the model training, etc. We have a field component, which is with a smaller footprint and can be run several times to be where we can run and download the models. And for sure, we have in the first step here also a connectivity part, because data is the baseline that we need. So Karina also has talked about hurdles and challenges that we have to overcome, and we have tried to show that in this slide here to give an overview what are our experience from the past and how we try to overcome them nowadays. So in the beginning, most of the time it starts with a great AI use case. Somebody has a great idea and wants to tackle that. And this is also what was already mentioned, some hype. So this is the curve that you might be familiar of from the Gartner hype cycle. So we start here with a great idea, and maybe sometimes after the POC, we are down in the valley of tears. Why is that? If you have a look at the success of implementation here, the first step is the data challenge. Nowadays we are quite good in that, but it was also mentioned in the Menti. This is one of the big steps. Then also finding a good model and doing the training, we are also still quite good. But then with growing that topic in a business-related sense, it gets more and more difficult because we have to roll out it. We have to have scalable IT infrastructures. We have to still improve the topic, and then in the end we get a positive ROI and a good solution that can be productive. And many or most use cases fail at this step, going from the POC in a bigger rollout, and we've shown this here also with these two symbols. So in the first two parts we can do that ourselves with our hands and our brains. And here later on, if it gets bigger, we also talk to other people. So this is also a big step to overcome then. And yeah, if we manage it, then we will get the business value in the end here. To give you some numbers and a feeling, what are we, what kind of ROE we can have in our own production, for example. This is a CNC machine that we run in our plant in Scharnhausen, opening doors for the tool change section. And we had some issues in the past due to crisps and out of aluminium and also plastics, because they are manufacturing both on the same machine. So this got stuck from time to time, and now we are monitoring the cylinders that are behind, the pneumatic cylinders. And by simply doing that, we can reduce the unplanned downtime, etc., by then also triggering our maintenance software smart tenants to clean up everything on time. So 15,000 euros per year with our costs that we have for machines, etc. This is where we are today. Now I want to hand over to Felix, who is going to show you a first real-world example.
Yeah, hello, I'm Felix, data scientist and software developer from Resolto, which is part of digital business. And I'm bringing you one first real-world example from the food industry. So there we have a customer where AX is running as a cloud application, so as a software as a service. And later on, I want to tell you something about this auto onboarding, one key feature which enables the scaling for us. So, yeah, what was the starting point in this project? We did a POC, and in this POC, we started at one of the factories of the customer. And first one has to have a great AI use case, and we found that. So there were several downtimes and breakdowns in the factory. And a lot of them were caused by valves, which were built in this sunny nozzle thing. And since the downtimes are costly, we had our AI use case. We had to address the data challenges, which we did, and we found a model fitting to the data we had, and most important, we had success with that. So we found breakdowns 5 days in advance. So the POC was successful, so we went into the next step where we are currently at. So now we went from one factory to several factories of the customer. And AX is now running in the cloud and not on-prem. And in this use case, the customer's IT takes care of the connectivity. So we can start with our field. And nonetheless, we had to integrate AX in their ITs, so we had to handle some cybersecurity processes. And in this step, we not only have the sunny nozzles as an application, but also cylinders. And there we can reuse the industrial app, MIP. Okay, reminding you at the whole architecture of AX, it looks different in this use case. We only need the core components, the field and the brain. On the left-hand side, the customer takes care of the connectivity, and the customer does not use our UI, but takes care of the visualization and persistence completely on their own. Okay, now to the auto onboarding. If we just have one cylinder and get data of one cylinder, it's all easy. You can add the features belonging to the data of the cylinder manually by hand. That can be done by anyone. You can train the model and add an asset to our asset view here. And this is all nothing special. But if you have a lot of cylinders on the left-hand side, you don't want to click one by one. So we have this auto onboarding magic, which is like a recipe. If data is coming on a specific MQTT topic, the rest is done in the brain on its own. So you just have to add the data in the right way, and AX does the rest. So we have the complete list without having to click anything in the UI. Okay, so scaling with the auto onboarding, the scaling in the one direction is pretty easy. So adding more factories is no problem at all for us. And the other direction, adding more applications, this is something which is under development at the moment. The customer, I mean, the 2 cylinders and sunny nozzles are done and the rest is developed at the moment. Okay, so now I can hand over.
Thank you very much, Felix. Can I give this presentable? Thank you. So yes, I'm glad to present you our holistic approach for body-in-white construction. Body-in-white construction in general is characterized by a relatively high degree of automation with industrial robots and by diverse types of manufacturing processes like fixing, grabbing, transportation, welding, gluing, etc. And our developed solution approach now does not focus on a single application. Instead, we spread our analysis approach across many applications. And these applications comprise, for example, roller conveyors. Here we are focusing on electrical drives. We also have a solution for the supervision of fixture and gripper blades. They are typically equipped with pneumatic clamps, vacuum grippers, and proximity switches. For welding applications, we also provide a solution here for the spot welding guns, as well as applications for arc welding. And we have a solution for gluing applications. Here we consider the adhesive dispensers. And last but not least, we also have a holistic solution for energy monitoring. Here we include electrical energy data as well as the pneumatic energy data. And we want now to leverage the benefits of a holistic database that contains also data about the interdependencies between these kinds of manufacturing processes. Beside this, when we developed our approaches, we have a strong focus on the real-world challenges. For example, the data quality or the changing environmental conditions in the automotive industry. And in the next 2 slides, I will give you 2 examples how we cope with these challenges and how we can leverage these effects when we have a holistic database of these manufacturing processes. The first example considers vacuum grippers. They come in a high variety, ranging from simple Venturi nozzles that provide only 2 physical signals, but up to more advanced vacuum ejectors that provide more physical signals and sometimes even also onboard diagnosis information. Then we also have different vendors of these vacuum ejectors, and our developed approach starts now with a time series processing, including feature engineering as well as cycle detection. Then we developed an ensemble-based anomaly detection model that is trained in an unsupervised way, and subsequently we use a rule-based classification algorithm using also unsupervised training techniques by incorporating domain knowledge. And with this ensemble-based approach, we can now address multiple different real-world challenges. What this ensemble do, we combine different submodels to a consensus decision in such a way that the predictions of each submodel can complement each other. And in this way, we achieve here more robust and more precise predictions of this overall ensemble. Beside this, we can also reconfigure the submodel structure of this approach to support different types of vacuum ejectors. In this way, we achieve for this PIAP vacuum ejector an average overall fall detection rate of almost 80%. I think this is a quite good number for real-world applications. And when we dive into the single faults, then you will recognize that faults related to leakages, for example, in the suction cups or in this vacuum ejector, we can detect with a fall detection rate of almost 100%. As you may have noticed, we have problems here in detecting low pressure faults. That is when there's a leakage in the tubing, for example. We cannot detect this with this ensemble approach. However, we can detect it with our energy monitoring approach, because here we include the electrical data as well as the pneumatic data in a holistic database. We can then calculate cyclic energy consumption values for production cycles, and these consumption values are then aggregated along the hierarchy levels in manufacturing, and this allows us then to make a drill down to the pressure supply systems like hall installation blades or robot installation blades. And based on this pressure and flow data, we can apply machine learning models to classify the different system states of manufacturing processes by simply considering this input data. And in this way, we can then detect low system pressures, also when they're located between the tubing from a valve ejector to the valve terminal, for example. And this is an example how we can use this holistic database. There are many more examples how we can profit by using data from multiple applications across all the welding cells. So what is the current state of this project? Currently, we deploy our solution at a customer in the automotive industry. And here we also use the auto onboarding approach to roll out thousands of machine learning pipelines for a total 8 applications. And we also developed together with the customer an approach to integrate the machine learning model predictions into their manufacturing execution system, as well as into AX maintenance that enables us then for digital maintenance and incident management. With regard to the performance requirements, I think we're facing there quite challenging requirements. We have to process over 600 megabytes data per second per body invite line, and to have 4 weeks of historic data per 1,000 applications, we have to hold 4 terabytes of data. How do we cope with these requirements? Well, we can use our flexible architecture, and we split the containerized software components across different execution devices. So on edge at the OT and IT level, we realized the connection with a customized PLC connector using the Kafka and MQTT communication technology. Then we are using multiple Festo AX field instances to extract information-rich feature set. And in this step here, we reduce the high amount of data by a factor around about 50. And then we send this data to a central running instance of our Festo AX brain, where then the deployment of the machine learning pipelines is managed, and also the machine learning models are trained. Based on this brain component, we then also realize the interfaces to third-party systems like the customer MES, where we then can close this machine learning loop with the underlying applications. So, Steffen, do you want to conclude the talk?
Yes, thank you, Yannick. So, what have you seen now in these examples from real world? Addressing data challenges, we tackle it via domain knowledge. So knowing about the processes, knowing about the products, the data that we can get from it, this is step number 1. And also, domain knowledge helps a lot to use appropriate ML models. So you saw the vacuum example, you saw the energy insight example. So really understanding what is behind the technology helps you to really get good results. To overcome the IT infrastructure topic, to really get in larger scale rollouts, there we have the 2 approaches with our standardized apps versus customized solutions, where we can adapt our architecture to the customer needs. And for sure, creating closed loop machine learning systems by integrating it into existing business processes, like in the example of Yannick, where we really also use existing user interfaces, existing systems with which the workers already do their daily business. So this is also a very big approach that we can do that here as business integration. So thank you all for your attention, and if there are any questions left, probably also from the moderator, we are happy to answer.
Thank you very much. Also, we're in time, and already a question. Great.
Great talk. Thank you. So I was curious how you mentioned closed loop, and obviously there's a lot of data coming in, which has a potential to also update the machine learning based models. how you're dealing this sort of incremental maintenance of the models themselves.
So this is currently the step where we are in our development roadmap with Festo AX. So versioning models, versioning we call it asset type. So if we are talking about vacuum insights, for example, or cylinder monitoring, then this is an asset type. So there will be a versioning behind it so that we can update the model approach through all of the instances that we have, all the onboarded assets. They will get the new version of the model. This is currently the next step with our next version. Yeah.
Great. Other questions? Wow.
When we compare to our main competitors that we have, do they have similar programs like this, or is this some kind of USP that we are having here? Or
maybe let me answer that quickly as well. So I think the approach with that standardized apps, this is something more unique than the customized solution approach. So project-based business, there's a lot of other companies, also startups in the market, but maybe you have noticed on the last slide that we think that we as Festo, with our large background and lot of knowledge within automation technology and also domain knowledge at our customers, that we can bring more benefit for the customers into that due to that reason. Yeah.
Thank you. It was a very good talk. So when it comes to data security, how we handle it, do we also have to share the data we collect with our customers?
Basically, now in our installations, the data stays at the customer. So the installation is on edge, on the virtual machine at the customer. So basically, the security level that the customer has in its own infrastructure, like firewalls, etc., this is also the baseline for us because the data stays there. So that's the basic answer to that.
How much work does the AI part actually represent compared to the overall infrastructure work you have to do? Is it significant? Is it like half-half, or is it rather minor? And do you see room for much progress there, or are you saturating?
It's a good question. So I think it depends whether we talk about POC phase or the rollout phase. I think in the POC phase, AI model approach, etc., was really the main work, and this is also why we started with some pre-staged or prepared installation, like with a box where we have the edge device inside, and we simply drop that at the customer and let it stay there, that we don't have to deal with the infrastructure too much. So then Yannick and Felix, they could really focus on the hard work with the modeling, and then later on the larger discussions come then with all the infrastructure.
So after the Valley of Tears.
Right.